Hi, welcome to Spark channel. So on this lesson we're going to work through grade 12 and 11 question paper. So this is from the past paper and they want us to answer the following questions, but let's make sure that we understand the statement and the diagram, and we also know the forces that are acting on these two crates. So they said that a crate P of mass 1.25 kg is connected to another crate of mass 2 kg, and the one with mass 2 kg, that's our crate Q. So now they say these two crates are placed on a rough horizontal surface. So this tells us that the surface is rough. So since the surface is rough, these two guys will have frictional force. So surface A, they say that we have the constant force of magnitude 7.5 acting at angle theta to the horizontal, and we can see that it's applied, and we are also given the acceleration as 0.1 meters per second squared. So the first question, they want us to state Newton's second law. We are coming to this statement. We're going to go through this statement, don't worry. Newton's second law, I'm not going to work on that. I need you to go and consult your exam guideline, how to define Newton's second law. So the first question that I'm interested in, they want us to draw the free body diagram for crate P. Look at this crate P. We can see that on crate P, I'll have a force moving in that direction. We're going to call that force of tension. Then the other force, remember this force they said it's on a rough surface. So we'll have another force moving in that direction, and we're going to call this our Fk, the kinetic friction, or we can call it friction. Let's just call this frictional force. So we're just gonna call it Ff for frictional force. Then I have a force moving up, which is always perpendicular to the surface. This is my normal force. And I'll have the force that always acts down, which is the force of gravity. So my free body diagram will look like this. Normal force pointing up, Fg going down. We have tension. Remember, if this is 4 marks, this tells you that you need to indicate 4 forces. So let's say this is my frictional force. Okay, so now we are done answering the 2.2 question. So now 2.3, they want us to calculate the magnitude of the tension in the string for 4 marks. Let's go back to the statement. Look at the statement. It says that crate P experience what? A constant frictional force of 1.8 Newton, and crate Q it experienced a constant frictional force of 2.2 newtons. So now what I'm going to do for us to find the tensional force, first thing first, you need to know what is tension. Tension is that horizontal force. So I'm just going to indicate that guy there. So look at this. My tension is the force that is horizontal. So I'm going to indicate all my horizontal forces. Right, so when we indicate all my horizontal forces, there's another horizontal force that we need to include on our calculations. We need to be very, very careful with that one. But now, you know what I'm going to do, because I can't use this one, crate Q, because we have another one here, which is Fx. So if we use this one, the angle is not given. This will make everything to be more complicated. So I'll only work with crate P. So I have to draw the free body diagram for crate P for horizontal forces. So I'll have my tensional force in that direction, and then I have my Fk. This is my kinetic friction. So this is my Fk. So now when you have this free body diagram, we need to choose direction. I'm going to take the direction of the motion as positive, meaning that I want everyone to say right is positive. So now if I use the formula F net, it's equals to MA. I need to take tension, then subtract all the forces that are going to left, equate this to MA. Why are we subtracting all the forces that are going to left? Because we choose our direction right as positive. Okay, so now if you understand that part, we need the kinetic friction of what? Of crate P. Remember, this is for the crate P. This is the free body diagram for the crate P. So let's go to the statement. They say crate P experiences a constant frictional force of what? 1.8 newtons. So where there's Fk here, we're going to substitute T is equal to minus 1.8 newtons. Now, what about the mass? What is the mass of the crate P? It's 1.25. So now I'm going to say this is the mass of 1.25, right? So the acceleration of this was also given. Look at this statement. The crate, I'm just gonna try and highlight that part. I'm trying to move slow here. So the crate of this, the acceleration was given as what? 0.1 meters per second. So where there's A, I'm going to substitute 0.1. Let's put it here and say this is 0.1. The only thing left is for you to find tension. This was easy marks, né? So the tensional force will be equals to, on the right hand side we have 1.25, which is multiplied by 0.1. Then we need to move the 1.8 to come this side to be positive 1.8. So the answer that you get, it should be your tensional force. So tensional force is equals to, we need to punch that on the calculator. So we need to put this on the calculator. We need to say 1.25. We're going to multiply that by 0.1. The answer that we get, we need to add 1.8, which gives us the answer of 1.925 newtons. So the answer is 1.925 newtons. So now we need to follow the instructions. Most of the time in the question paper, they'll tell you that you must round off your answer to what? You must round off your answer to the nearest. They'll say round off to 2 decimal places. So this will be the tensional force. It will be equals to what? The tensional force will be equals to T is equals to 1.93 newtons. That's how you calculate the tensional force. If you are happy with that, let's move to work on the next one. This is also 3 marks. Let's look at what they want on the next question. They want us to find the angle theta. Let's go and see where's angle theta. Look at the angle that they need us to calculate. So what I'm going to do, remember this has to do with vertical and horizontal components. So this one going up, it's my Fy, and this is my Fx. So now, what I'm going to do, it will be easy if we use Newton's second law. Right? So if we use the Newton's second law, we'll have to indicate all the forces that are acting on crate Q. Please make sure that you indicate the correct forces, but horizontal forces. Remember, we changed the applied force into a horizontal component. So this will be my Fx going to the right, and I'll have tensional force going to the left. Remember, we still have the tension. The tension will oppose the direction of the motion. I'm sorry, not the tension, but the frictional force. So this will be my Fk. So this will be the 3 forces that are acting on that diagram. So this tells me that if we use the formula F net is equals to MA, we need to choose. Remember, already we chose our direction right to be positive. So we already said right must be positive. So I need to take all the forces going to the right. Then I need to subtract all the forces that are going to the left. So this is what I have so far. So now from this, I know that Fx is equals to, guys, we don't have time to explain the basics now. Now I just know that everyone knows that Fa is F applied times the cos of theta. So meaning that where there's Fx, we need to put F, times the cos of theta, then we minus Fk minus the tension is equals to Ma. Now let's do the substitution. Let's substitute what we know. We know that the applied force was given as what? 7.5 multiplied by the cos of theta. Remember, we are looking for that angle theta, because the angle, this angle is the one that we substitute on our horizontal component. This is the angle that we are looking for. So we're going to minus the kinetic friction that was given. Remember, the kinetic friction of crate Q was given as 2.2. So I'm just going to substitute this as 2.2 minus the tension that we calculated. So if your tension is wrong, this will affect the next answer. So this is 1.93 Newton. So I'm going to minus 1.93, equate this to the mass of 2, and the acceleration was given as 0.1. Look at this. We only have one unknown, which is theta. We need to find that value of theta. So I'm going to make this thing easy. Remember, I can write it as 7.5. The cos of theta, I can equate this to 2, which is multiplied by 0.1. Then I'm going to move the 2.2 to the other side to be positive, and also we're going to move the 1.93 to the other side to be positive. Now what's next? We need to divide everything by 7.5. The whole answer that you get here, everything that you get there, you need to divide it by 7.5. So now these two will cancel and will be left with what? The cos of theta. So if we continue with this problem, we'll be left with the cos of theta is equals to that 2 into 0.1 plus the 2.2 plus 1.93. Everything, the answer that you get, remember we need to divide it by 7.5. So I'm just avoiding to make mistakes. So therefore, the cos of theta, not the cos of theta, but theta, remember to make theta subject of the formula. Theta will be the sine in, theta will be the cos inverse. So theta is just the cos inverse of everything, which is 2 into 0.1. We add 2.2. We add 1.93. And everything is divided by the 7.5. The answer that you get there, it should give us the angle theta. I hope we did not make any mistakes. So now let's punch this on the calculator. We are looking for the cos inverse. Then we have 2, which is multiplied by 0.1 inside the bracket. Okay, then we're going to add 2.2, we add 1.93, and then what's next? We divide everything by 7.5. Yeah, let's see what we get. We get our angle theta as, okay, the angle theta should be 54.74 if you round it off. So theta is equals to 54.74 degrees. So now the most important thing about this type of questions is for you to be able to know all the angles that are acting on a certain object. If you can be able to know all the objects that are acting on that object, everything will be easy for you. You'll be able to apply Newton's law. And that's it for this lesson. We just wanted to make calculations, and then our free body diagrams are correct. You see, each and every calculation that I do, I start by doing a free body diagram. So thank you very much for watching the lesson. If you liked the lesson, please make sure that you subscribe so that you don't miss the next lesson.